poppin' YouTube? It's your boy Achint, back at it again with another sorting algorithm on the SoftBoarders. Today, we're going to be exploring selection sort. Now, I want to be able to explain a sorting algorithm so even people without a CS background are able to grasp onto the simple understanding of how sorting works in general. Maybe you might be using it in a different field, I don't know. Well, tune in to find out more. Let's go. Alright, now, I just want to start off by saying that algorithms are really easy to analyze if you just walk through what they do and find the simplest case there is when you want to solve it. Now, for selection sort, the best analogy I can give you is a baby sorting a bunch of blocks. Selection sort, by principle, is a child algorithm. What's it going to do? If you were to give a baby maybe 3 blocks, but you have to tell them, okay, can you arrange them from smallest to biggest? What's the baby going to do? It's going to take the smallest of the 3. And then it has 2 blocks left. And it's going to take the smallest block of the next 2 and sort it. And then the last one, by default, is the minimum of that one element. And it plucks it and puts it there and sorts it for you. That is what selection sort does. Selection sort essentially splits the pool into a sorted pool and an unsorted pool, and sorts it for you based on plucking the minimum from the unsorted pool and putting it into the sorted pool. This is a truth called an invariant in any sorting algorithm that stays true throughout the entire sorting. Let's just write down what an invariant is. An invariant is any truth that stays true throughout the entire sorting of the algorithm. Now, in our selection sort, or even in the baby's example, let's just show how the invariant stays true. Let's say the baby got 3 small blocks, or blocks of that size. The baby needs to sort it. Now, let's just call this the unsorted pool. And this is the sorted pool. Now, what's the baby going to do? It's going to take the smallest of the 3. Goodbye, and hello over here. Now, what's it going to do again to sort it? It's going to take the next minimum. Now, this is what's the truth I'm going to tell you about. The truth is really simple. On the sorted side, you have all the minimums put in ascending order, simply because you're constantly plucking the minimums from the unsorted side. Now, if I had an item of 3 and I plucked in the minimum, the new minimum of the unsorted pool would be the second smallest thing, as it was before. That's all we're doing. Since I plucked this box out of the unsorted list, this is my new minimum because it was the second smallest. And now I'm going to pluck that and put it into my sorting pool. Sounds good, right? And now, essentially, by default, if you had one item, that item would be the minimum of the entire one item set, right? So that's taken care of if we just pluck it out and put it there. Voila! Sorted. This is the truth. The truth is, for people to sum it up completely, when you pluck the minimum from the unsorted side, you are basically comparing it against all the elements against it in sorted order because you're plucking the minimum constantly one after the other. And therefore the minimum gets swapped, and as soon as you keep stacking them up in the sorted pool, you have a completely sorted list. Now, you mentioned how I was saying it's going to pluck the minimum. It's really simple because all we need to do is explain selection sort in the lens of a find helper. All we need to do is explain selection sort with a helper function. Our helper function will be called findMin, since we were plucking the minimum from the unsorted pool to the sorted pool. Now, since we don't want to waste a lot of space, we want to do the sorting in place. So in our condition, let's just try to fix the array in place. Let's say, for example, I have an unsorted array of 4 elements, 2, 69, 420, and 83. Now, Selection sort is essentially going to assume that the sorted pool will start from the left side and everything else will be the unsorted side. Now, it's going to pluck the minimum and put it in the first place. Well, 2 is already there in the minimum, so we don't need to do any plucking. Now, it's going to move 1 down and treat this subarray to find the next minimum from. What's the next minimum here? 83 or 69? It's 69. There you go. It's sorted again, so we don't have to do any replacement. Moving on. Here's where it gets a little bit interesting. Now that we've moved our range of solving from 420 and 83, we're going to have to do a little bit of comparison. What's the minimum amongst in this sublist of size 2? It's 83. There we go. So we're just going to swap 83 and 420. And there we go. Voila! And when we move on to this side, 420 is the de facto minimum in a size of list 1, or in a sublist of size 1. And we have a sorted list, right? That's it. Alright, so now let's go into the code. I'm going to be writing it in Java, but if you guys prefer Pseudo Code, you could just always, follow the ideas, mainly besides the code. Now, let's just call it find minimum. But since we want to do the sorting in place, I want to return the index, so it'll be easier for me to do the swapping in selection sort. Let's just call it find min. Alright. Find min essentially has a big array. Let's call the big array A. It's going to take in a list called A and an index, an integer B. Let's call this big list A and divide it into the sorted half and the unsorted half. And this will be B. And this entire big list will be A. Now, what's it going to do? Since we want to return the minimum from this side of the list, all we're going to do is plug it out. We're just going to store the element at B, since we want to be able to do the comparison faster. So let's call it integer cur index, or cur int, is equal to B. And integer current value is equal to the element at B. Now, what we're going to do is we're going to run a for loop through this side of the list so we can effectively do the comparison to find the minimum of the unsorted half versus the sorted half. That's it. So we're going to run a for loop. For from B plus 1 to the size we're just going to compare if the element at B plus 1, or let's just call it J is equal to B plus 1, sorry about that. If the element at J is less than the element or the cur value, we're just going to swap them. Now we're just going to make cur value equal to a dot at j. And then we're going to assign the current index equal to j. And then we're just going to return at the end of the for loop the value. Excuse me, sorry, we're going to be returning the index. That's all find min does. All it's going to do is it's going to take the element at B and it's going to move on. If there is an element less than B, it's going to make that the new minimum. And then it's going to move on to the next element. If it finds an element lesser than itself, it gets replaced by the new minimum all the way until it reaches the end of the list. And by default, you have found the minimum of that list. That's all there is. And see how the truth remains the same, that you are plucking the minimum and then putting it in here? That's the selection sorting part. We're just finding the minimum here, which is the basis to solve for selection sort. Now that you guys have a grasp, I'll just take a minute. If you need to help solve it, just pause here. If you want to read through the code and understand it, walk through a little smaller examples, and we can move on. For selection sort, we're just going to need a list. We don't need to take anything else, right? All right, guys, now it's for the big time. All we're going to do is run a for loop through the entire list. All we're going to do is we're going to treat the sorted side as a growing pool, essentially. So what we're going to do is we're going to go from for 0, for j is equal to 0 to the size of the list. We're just going to call find minimum on the other half. Make sense? We're just going to call that 1 for simplicity's sake. What's it going to do? We're just going to go swap. Now, what's the for loop going to do? We're just going to find the minimum on this half of the array. We're going to find the minimum on this side of the array, and we're going to swap it. That's it. So all we're going to do is we're going to call it int cur_min is equal to find min. But A and J, because remember how we were passing the index? That's the problem. And all we're going to do is swap cur_min, since it gives us the index. My apologies. We're going to have to swap the element at cur_min with the element at j. Now, that's it. That is selection sort. So, if we're going to walk through a small example, what's it going to do? Let's say we had a list of 3, 6, 19, my bad, sorry. Let's do 23, 19, 64. All right? What's selection sort going to do? We're going to start at 1. All right? What we're going to do is we're going to start at 1, and it's going to find the minimum of this side of the list. So the minimum is 19. And since we're already at the current minimum will be 19, we're going to be, oh my god. Sorry guys, that should be a 0. I made a small mistake. So now what's it going to do is it's going to find the minimum of the entire list, since our list is now completely unsorted, right? So it's going to find the minimum, which is 19, and it's going to swap the current minimum's index, which is 1, with the element at 0. So it's going to swap 19 and 23, and that's done, yeah? So it already does a swap, and we're good. That's the reason why we took the index, is because we want to do the swapping in place. Now, it's going to move on to the next list. What's the minimum? So now j gets incremented because it goes to 1. And now between 1 and the rest, 23 is already the minimum. So it doesn't have to make any more swaps since the minimum already occupies the same spot. Swapping an element at the same index is essentially putting it in place. And the same thing repeats for 64. Since 64 is default the minimum, it will be pushed into the list. We could do another big example, but I'm pretty sure you guys are able to do it. This is selection sort, guys. For all of you comp sci nerds out there, since find minimum goes over the list once, it is an O of n operation. Essentially, for non-computer science majors, the amount of time that it takes for find minimum to run goes up against the size of the list. And since we are running an O of n function across an entire list, we're going from here to here to here. Essentially, we are running the operation n number of times, and then n minus 1 times, and then n minus 2 times. And by the geometric sum that goes from n plus n minus 1 plus n minus 2 goes all the way down to 1, the sum of that is n squared divided by 2. So the running time of findmin due to the one iteration is order n, and due to selection sort running an order n operation n number of times, the running time of selection sort is in big O of n squared. Alright guys, that's selection sort. Essentially taking the minimum, plucking it out, and putting it into our sorted list. Thanks for watching guys, and I'll be catching you in the next video I'll be making insertion sort.